Welcome to Lesson 8, the SpotOn Game app. Now in the previous lesson we showed you the Canon Game app where we did some animation, and the animation that we did was all done manually by us. We had a separate thread of execution that controlled our animation game loop, and from that separate thread of execution we were able to update the positions of all our game elements on the screen and then redraw them at their new positions, and we just kept doing that repeatedly until the game was over. Now in this app, which is specifically designed to run on an Android tablet at the time of this recording, using Android 3 and higher. In this app we're going to introduce the concept of property animation. Now before Android 3 there were really three key kinds of animation. There was the kind of manual animation we did in the previous lesson. There was a concept called tweened view animations, in which you could change limited aspects of a view's appearance, such as where it's displayed on the screen or its alpha value. There was also a concept called a frame view animation, in which you could display a sequence of images. Now with Android 3 they introduced this concept called property animations, and these are interesting because you can animate any property of any object. It's not limited to just views. So if you have a value that you want to change over time on a given object, you have the ability to do that with property animations. Now within the concept of property animations we have some key pieces of information that we need in order to implement an animation. Basically we animate values over time, and to do that we need to know the target object that we're going to animate. In this app we'll be animating green spots and red spots that will be displayed on the screen. We need to know the property or properties that are going to be animated. So for example, when I test drive the app with you in a moment, you'll see that the spots that show up on the screen start at a certain size and then they begin moving and they begin shrinking in size at the same time. So we will be changing their locations and their size as the animation continues. We need to also know the duration of the animation, so you'll see that when the spots move, they only move for a certain period of time and then they vanish from the screen. If you miss them, you have to touch each spot to remove it from the screen to increase your score in the game, as you'll see. We need to know what values to animate between for each property as well. So for example, for the size, we'll start each spot at a certain size and then we will reduce that size over time, so we need to know the starting size and the ending size. And then finally we need to know how to change the properties over time using what's known as an interpolator. And of course we're going to demonstrate all of these capabilities to you as part of this app. And within the property animation capabilities that were introduced in Android 3, there's a couple of key classes. There's a concept called a value animator, which allows you to change property values over time. And with such an object, you can use an animator update listener, and that gives you animation events that allow you to respond and change property values. And this can be handy if you have an object that doesn't have standard set methods for changing property values. On the other hand, there's also a subclass called Object Animator, a subclass of Value Animator that is, and its job is to specifically use standard set functions to modify property values over a period of time in an animation. Now, as of Android 3.1, which is what we'll actually use in this app, they introduced a new class, a new utility class called View Property Animator, which greatly simplifies even further the ability to animate properties on an object. And that's what we're going to be focusing on in this app. Now every view has an animate method that allows you to obtain a view property animator, and then you can chain a bunch of method calls onto that view property animator to configure your animation, and as soon as the last animation call, or the last method call rather, in the chain executes, the animation starts running for you automatically. Now, we're also going to, in this app, deal with various touch events. We have two different categories of touch events, as you'll see when I move over to the tablet to demonstrate this in a moment. We have the concept of touching one of the spots on the screen, and we'll use click event handlers for that. And then we also have the concept of missing a spot entirely and just touching elsewhere on the screen, and for that we'll override the onTouch event method that we introduced in previous lessons. So let's go ahead and switch over to the video now and actually take a look at the SpotOn game running on our tablet. And by the way, you can run this on an Android 3.1 or higher emulator. However, at the time of this recording, the emulator's performance is not that good, and therefore it can be kind of a slow experience to play the game on an emulator. So if you have a tablet available to you, I highly recommend that you run this and install it directly onto a tablet. That way you can get the real experience of the game. So as you can see here, I've already installed SpotOn. Here's my icon for it, so I'll just touch it. And before playing, I'll just let you see the animations that are going on. We have some sounds, so as a spot disappears, the sounds play indicating that you missed those spots. And in this case, all of the spots disappeared, and I had a game over dialog appear with a score of 0. I can hit the reset game button to start a new game at this point. So you can also see just a couple of other elements while I'm looking at this here. We're maintaining a high score. That high score was from weeks ago when I was first testing this app on the device, and so you can see that we're saving that information with the app so that the next time we run the app we can see the previous high score. Of course, if you get a new high score while playing, we'll store that permanently on the device. We have the current score displayed below that, and we also have the level displayed. And the way this game works is every time you touch 10 spots, it moves to the next level, and now the spots start to animate more quickly, and the game gets harder as you go. Also, as you touch each spot, you get a score, which is 10 times the current level per spot. If you miss a spot, then you lose 15 times the current level. So accuracy is important as well. So let's go ahead and run the game again. And you can see here, as I touch each spot, it makes a noise. And you can see them start to move. The further they move, the faster they appear to go, because the animation time duration is the same regardless of how far they're moving. And therefore, the farther they go, the faster they appear to be going. And the game just gets more and more difficult as you go along. Every time you touch 10 spots, you also get a new life, and I'll just let it go to the end now. And we get our final score dialog here, showing that the game is over, the final score. I can reset the game, and of course you can also see that this was not the new high score in this case.